So what we learned so far? Let's review a little bit. We learned about parametric equations. For example, x is a function of variable t, y is a function of variable t. We learned that we can take the derivative of these parametric equations. So this is called parametric equations. So dy over dx is actually the derivative of y with respect to variable t divided by the derivative of x with respect to variable t. Of course, you can flip this and say, hey, I have dx over dy, which is defined as dx over dt over dy over dt. So d is just an operator. In linear algebra, you learn about this linear operator. Very well. So we are on page 7 on 10.2. So what do we have here? Let's see. Okay, we're done with this example. It was about this. Let me write this quickly for you. This example was about your curve C, and this curve is defined by x equals to t squared and y equals to t cubed minus 3t. Very well. Our goal was to show that we have two tangent lines at point 3 and 0. We have two tangent lines at 3 and 0. So this is just a review. Let me write this for you. Again, remember that to write equation of tangent line, we have y equals mx plus b. What is m? M is the slope of the line. To find m, we need to find the rate of change of the function. So to find m, first we have to find the derivative of the function, then plug in these values to find your t and write down equation of tangent lines. Okay, if you remember that y prime was 3t squared minus 3 divided by 2t. So what is t? To find t, what we did, we plugged in 3 for x and 0 for y. 3 for x is equal to t squared. This guy gives you two solutions for t. T is positive square root of 3 and t is negative square root of 3. Very well. This is for our x, and for our y, we plug in 0. 0 equals to t cubed minus 3t. By solving this, we can factor out t. It gives us 3 possible solutions. And t equals to minus square root of 3. Now remember that if you plug in t equal to 0 for the derivative of the function, you get 0 on the denominator and it's not acceptable. So for different values of t, we find m. M is equal to 3 times square root of 3 squared minus 3 divided by 2 times square root of 3. M is equal to 3 minus square root of 3 squared minus 3 divided by 2 times negative square root of 3. By solving this one, we have 3 times 3, 9 minus 3, 6 divided by 2 square root of 3. Remember that we multiply this by square root of 3 to rationalize the denominator, and we could cancel out these. We get square root of 3 as the slope of the line. And for this one, after calculation, we got negative square root of 3. So since we have two slopes, it means that we can write two equations of tangent lines. Y is equal to square root of 3 times x plus b and y is equal to negative square root of 3 times x plus b. Very well. Our x is 3, our y is equal to 0. So here you have b equals to negative 3 square root of 3. And for the second equation, you have b equals to 3 times square root of 3. So this is what we did on Monday. We are on page 8. We're going over a new example. Page 8. This example says, find tangent line to the cycloid which is defined as x equals to r times theta minus sine theta, and y is defined as r1 minus cosine theta, where theta is equal to pi over 3. And okay, this is the first part of the question. We're going to solve this, then we're going to move on to part B of this question. Very good. So what's the question asking? Question is asking to write equation of tangent line, any line. To find equation of tangent line. Any line has equation y equals to mx plus b. Very well. We're looking for y, we're looking for m, we're looking for x, we're looking for b. First, let's find slope of the line. So first, find m by taking the derivative of the function. Derivative of parametric equation for x and y, which is x equals to r theta minus sine theta, and y is equal to r times 1 minus cosine theta. So these are the steps that we have to take to write equation of this tangent line. Okay, the derivative. dy over dx. Since y is a function of theta and x is a function of theta, we are taking the derivative of y with respect to theta. We're taking the derivative of y of x with respect to theta as well. So first of all, r as a radius can be any number. Copy down your r. The derivative of theta is equal to 1 minus the derivative of sine is equal to cosine. I made a mistake, yes. So the derivative of this is y, the derivative of this guy, cosine, so it's plus sine. Okay. And then the derivative of x, r1 minus cosine theta. This is the derivative of this parametric equations. Now we know that theta is equal to pi over 3. Let's plug that in. So m is equal to, you can cancel out r and r, get 1 plus sine of pi over 3 divided by 1 minus cosine pi over 3.
Excuse me, sorry, Professor. Isn't the derivative of...
Guys, the derivative of 1 is equal to 0. So this is 0 plus sine theta. Is correct? So on the numerator, we only have sine of pi over 3. Thank you, guys. So here you have sine of pi over 3. This is square root of 3 over 2. Divided by 1 minus a half. You get square root of 3 divided by 2 over a half. So you can cancel out 2 and 2. This is square root of 2. Slope of the tangent line is equal to square root of 3. And is square root of 3. Very good. Okay, so y is equal to square root of 3 times x plus b. What is y? What is x? And how we can find b? Very good. Your theta is equal to pi over 3. So your x and y can be found using pi over 3. So since theta is pi over 3, so your x is r times pi over 3 minus sine pi over 3, and your y is equal to r times 1 minus cosine of pi over 3. So your x is equal to r pi over 3 minus square root of 3 divided by 2, and your y is r times 1 minus a half, or r divided by 2. Okay, we can use x and y to find b. So y is equal to square root of 3 times x plus b. So b is equal to y minus square root of 3 times x. There you go. Y is r halves minus square root of 3 times r pi over 3 minus square root of 2 divided by square root of 3 divided by 2. So this is your y. You can simplify this by distributing this into parentheses, but you can leave it as it is. So your b is equal to r halves minus pi r square root of 3 divided by 3 plus 3 halves. So y is equal to square root of 3 times x plus b. So part B of the question says, so this was tangent line. Part B of the question says find points on the graph of the function where the tangent is horizontal. So what's the meaning of that? It means that slope of the line is equal to 0. Tangent is horizontal. It means that slope is equal to 0. So the derivative of the function dy over dx Okay, it was r times 0 plus sine theta divided by r times 1 minus cosine theta. So remember, we could cancel out r and r. This is the derivative of the function, sine theta divided by 1 minus cosine theta. So when it comes to a quotient expression, this is 0 if and only if your numerator is equal to 0. Sine theta is equal to 0. And note that the denominator cannot be 0. So 1 minus cosine theta cannot be 0. So if you solve this, you get 0, you get pi, you get 2 pi, and so on. And note that cosine theta cannot be equal to 1. For example, theta cannot be, for example, let's say 2. Zero. So let me write this here and the rest of them. So by solving these two equations, theta is 2n minus 1 times pi. So when your theta is equal to 2n minus 1 times pi, you have points on the cycloid that the tangent lines are horizontal. Very well, you learned about finding the area between graphs of functions and finding the length of the curve. So we are on page 9, 10.2. So remember that, recall. Suppose you have a graph in xy plane, x-axis, y-axis, and suppose you have this graph here. The graph of the function, like this. This is your function y, and your goal is to find this area. To find this area, we use integral. So suppose it starts from A and stops at B. Area A is equal to the integral. X ranges between A to B of function y dx. So if you have a function written in Cartesian form in x and y, this is the formula that we learned to find the area of a function. Now the question is, what if I have a function written in parametric equations? Parametric equations. So let function f or curve C that representing the graph of function C be the graph of function x is defined as f of t and y is defined as g of t. Then by using parametric equations, we can define the area this way. So area is equal to the integral. Your y is g of t. Y is g of t. And you have to find dx, the derivative of your x, which is f of t. And you have to find the lower limit, upper limit for variable t. So let's follow the book. Beta and alpha. T ranges between beta and this is the equation or the formula to find the area using parametric equations. So let us write this little formula down here for you. Area is equal to beta to alpha. So your function y, f of t, and g of t prime. This is the area of a region given by parametric equations. So we are still on page 9. Let us go over one example. In this example, it says, find the area under one arc of the cycloid. We know that x is defined as r theta minus sine theta, and y is equal to r times 1 minus cosine theta, while theta is between 0 to 2 pi. Okay. Let us start. The area A is equal to the integral. Our theta ranges between 0 to 2 pi, 0 to 2 pi, and your y value, your y, which is r, times 1 minus cosine theta, this is your y, and the derivative of your x. So we have to take the derivative of r theta minus sine theta. So r is just radius, is just a number. You can write r times r squared outside the integral. So r is the radius, which is a constant or a number. So area is equal to r squared, integral 0 to 2 pi, 1 minus cosine theta. And now we take the derivative of theta minus sine theta, which is equal to 1 minus cosine theta. Since we took the derivative with respect to theta, we have to add d theta. Okay, now we are getting back to math 1b, and we start taking the integral. Integral is equal to r squared, 0 to 2 pi. So let us multiply these two. We get 1 minus 2 cosine theta plus cosine squared of theta d theta. There you go. Remember that cosine squared of theta is 1 plus cosine 2 theta divided by 2. So the area is equal to r squared. The integral of 1 is equal to theta minus 2 times sine theta. And here we can replace this by 1 plus cosine 2 theta divided by 2. The integral of 1 over 2 plus theta divided by 2. And the integral of cosine 2 theta is a 4 sine 2 theta. And theta ranges between 0 to 2 pi. So let's plug in 2 pi. then we plug in 0 and we simplify. So area is equal to r squared. Let's plug in 2 pi. 2 pi minus 2 times sine 2 pi. We know that this guy is equal to 0 plus 2 pi over 2 plus a 4 sine of 4 pi. We know that this guy is also 0 minus. So, of course, if you plug in 0 here, all of these terms are going to be 0 minus 0. So the final answer is equal to, you cancel out 2 and 2, 2 pi plus 1, 3 pi, 3 pi r squared. Okay, let us move on to the next page. We're going to talk about the, let's see, length of the curve.
Professor, also to find the area, could we possibly like combine the two equations into its Cartesian equation and then take the derivative of that?
Yes, you can use this method as well. They're equivalent to each other.
Oh, okay.
If it's easy for you to combine FT, GT, that's absolutely fine. You can use this method.
Okay.
The same. So arc length. So what we learned so far, we learned that the length of a curve, the length of an arc is defined as the integral, for example, a to b of square root of 1 plus y prime dx. And when you have it in parametric form, your L is equal to the integral, for example, beta to alpha, the integral 1 plus. So here you get y prime. Remember the definition of the derivative of y. It is dy over dt divided by dx over dt. Let's write this down here, and dx. So if I just take common denominator between these two, I get L equals to integral beta to alpha square root of dx. Okay, I forgot to raise it to 2. This is the formula, raise it to 2. Okay. So you get dx over dt squared plus dy over dt squared the whole thing is divided by dx over dt squared. You can write it outside parentheses, outside your radical. You get dt over dx times this dx here. So you can get rid of dx, and this is equation of length of the curve in parametric format. So x prime squared plus y prime squared dt. We're deriving the formula from the Cartesian form that you learned in Math 2B, 1B, sorry. Example. We are on page 10 of the note. This example says, very well, here you have a function in parametric form, x equals to cosine t, y is equal to sine t, and t ranges between 0 to 2 pi. Okay. So I'm going to give you two methods. One of them is super easy, you already know that. Method 1, the first method. So x is equal to cosine t, y is equal to sine t. I have cosine, I have sine. If I square these two, x squared plus y squared, this is actually cosine squared of t plus sine squared of t. You all know that this is trig identity and this is equal to 1. What's the meaning of that? It means that you have x squared plus y squared equals to 1. What is this? This is a unit circle. Unit circle. So theta is between 0 to 2 pi. I know that, for example, this guy starts at, let me see, 1 and 0. So it starts at this point and it just rotates once and stops here. So what is the length? What is the length of this curve? The length of circle is actually the circumference of this circle, which is 2 pi r, 2 pi r, and we already know that r is equal to 1. So this curve has a length 2 times pi. This is first method for you. Second method is directly using the formula. Second method. There you go. L is equal to the integral t ranges between 0 to 2 pi square root of the derivative of x is negative sine raised to the second power plus the derivative of y, which is cosine, plus cosine squared, and we have dt. Okay, L is equal to the integral 0 to 2 pi square root of sine squared plus cosine squared is equal to 1 times dt. This is equal to the integral 0 to 2 pi of dt, which is t. T ranges between 0 to 2 pi. This is 2 pi minus 0, or just 2 pi. Using two methods, we get the exact same outcome. Find the length of the arc of the cycloid So the arc of the cycloid, so let's write this down. Here you have x equals to r theta minus sine theta, and your y is equal to r times 1 minus cosine theta, and theta ranges between 0 to 2 pi. Well, so we know that you have to take the derivative of x, you have to take the derivative of y, then raise both of them to the second power, then take they add them together and find the square root. So let's take these derivatives. The derivative of x with respect to theta is equal to r, 1 minus cosine theta, and the derivative of y with respect to theta is equal to r, sine theta. Now, the derivative squared, here we get r squared, 1 minus cosine theta squared, and the derivative raised to the second power is r squared, sine squared. Okay, perfect. So L, or the length of this arc, is integral 0 to 2 pi square root of r squared. This guy, if you write it in expanded form, is going to be 1 minus 2 cosine theta plus cosine squared. And here you have r squared sine squared theta d theta. So of course you can find out r squared and you can write r outside your integral. So L is r integral 0 to 2 pi square root of 1 minus 2 cosine theta plus cosine squared plus sine squared is equal to 1 d theta. This guy is equal to r integral 0 to 2 pi square root of 2 minus 2 cosine theta d theta. Very well, we can factor out square root of 2. So L is equal to r times square root of 2 integral 0 to 2 pi square root of 1 minus cosine theta d theta. Okay, now we have to take 1 minus cosine theta outside the radical. So let me write this up here for you. One minus cosine theta is 2 sine squared of theta divided by 2. This is 2 theta. I'm going to make a mistake here. So it is theta over 2. Yes. So here you have 1 minus cosine theta. We're going to use sine squared and get rid of this radical. So let me put star here. Put star here for you. This is equal to integral 0 to 2 pi and square root of outside it we have r square root of 2 and inside the radical. If you write this guy inside the radical, you get square root of 2 and here you have sine of theta over 2 d theta. So eventually you get r times 2 cosine of theta divided by 2. Remember that we have a negative sign in front of it, and theta ranges between 0 to 2 pi. So if you plug in 2 pi, here you get cosine of pi, which is negative 1. So negative, negative, write the whole thing, 4 times r. And here you have a negative sign in front of it. You get negative 1. And if you plug in 0, you get negative 1 again. So you get 8 r. So 8 r. This is your arc length. As you can see, we're using a lot of pre-calc. How to convert 1 minus cosine theta into other format. Then we're using integral. We're getting back to math 1b. So if you're comfortable about 1C, if you don't remember this, please get back to pre-calc, please get back to math 1B and practice, review those materials that you learned before, because you'll see a lot of things like this in this class.
Professor.
Surface area. So formula for your surface area, what you learned before is A equals to the integral of 2 pi y times square root of 1 plus y prime squared dx. Now suppose it ranges between A to B. So then we have parametric equations. We identify our y, we take the derivative, and we take the derivative of x, and actually we calculate the surface area. So on page 12, let us go over one example. Question says, show that the surface area, let's use S, not A, the surface area of sphere with radius r is actually 4 pi r squared. Okay. For a sphere, a slice is a circle. So when you are working with a circle, your x is r, for example, cosine theta, and y is r sine theta. So S is equal to the integral 2 pi y, 2 pi, my y is r sine theta, times square root of 1 plus the derivative of y squared, the derivative of y, r sine theta prime squared, times dx, the derivative of r cosine theta. And theta ranges between 0 to pi. So S is equal to the integral 2 pi r sine theta square root of. Very well. Let's see what do we have here. We have 1 plus r cosine theta squared times the derivative of r sine theta, which is negative r cosine negative r sine theta times d theta. So our S is equal to the integral. So here we have 2 pi, we have r, 2 pi r squared sine times sine, we get sine squared of theta, square root of 1 plus r squared cosine squared of theta. And here we have d theta. Now our goal is to simplify the whole thing.
Professor,
Yes.
what happened to the negative before our sign?
Negative is here. Let's put the negative sign. Okay, so if you use directly this formula, this is what you have to deal with. Equivalent to this formula, what you learn is S equals to the integral beta to alpha 2 pi, whatever your y is, times square root of x prime squared plus y prime squared, and here you have dt. So S is equal to the integral 0 to pi, 2 pi, instead of taking the derivative of x, we just write down dt, it's easier for us, 2 pi times y, which is r sine theta square root of the derivative of x, negative r sine theta squared plus the derivative of r of y is r cosine theta squared d theta. So I don't have to deal with dx anymore. And it's easier to simplify it this way. So we get the integral 0 to pi, 2 pi r, sine theta, and as you can see inside the radical, you get trig identity. You get r squared, sine squared theta, plus r squared, cosine squared theta, d theta. So S is equal to integral 0 to pi, 2 pi r, sine theta. Then here, if you factor out r squared, you get sine squared plus cosine squared d theta. This is equal to 1, and you get r outside the radical. So S is equal to the integral 0 to pi, 2 pi r times r, 2 pi r squared, sine theta d theta, which is equal to 2 pi r cosine theta, ranges between 0 to pi. Don't forget your negative sign. So here you have negative 2 pi r, and cosine of pi, negative 1, minus 2, negative 1, negative 2. This is equal to 4 pi r. Where's my r squared? Okay, excellent. And here you have excellent. Perfect.